Breaking news, there has been a major volcanic eruption in Ethiopia, specifically in the Afar region. This is quite surprising because Africa doesn't usually have volcanic eruptions, and when we do, they usually happen in the Congo. Although we do have the African superplum rising under the eastern part of the continent, forming the East African Rift Valley. And this is not really surprising because the pressure has been building up here for decades. We have seen a lot of activity a little further south, near Dauphin and Fontal volcanoes. In the last few months, about 6 months ago, 12 months ago, there has been a major intrusion of the magma vein. We have had steam explosions, large earthquakes, up to magnitude 6, which suggests that the overall activity is increasing, although it may be mostly below the surface. Now we can articulate that, and this is the first volcanic eruption that has occurred from this volcano, Haile Goubi, in over 10,000 years. It's the first volcanic eruption in recorded history. As far as we know, here, a giant column of ash rises from the ground like a mysterious signal from deep within the earth. About 5 million people live around a chain of volcanoes along the East African Rift Valley. And if the activity continues to escalate, the situation could become alarming, however, on a geological timescale. Most volcanoes here contain low viscosity magma, so violent explosions are rare. Today's phenomenon reflects that kind of gentle eruption, but it is enough to keep scientists watching closely. From a satellite perspective, the picture becomes clearer. The ash cloud has been quietly drifting across Yemen skies for the past 12 hours, rising as high as 3,000 meters, and possibly even higher than initial estimates. What makes researchers particularly curious is that this is the first recorded eruption in 10,000 years. This long geological lull raises an intriguing question. Is this simply a natural fluke, or is it a sign of a new cycle of activity emerging beneath the Earth's crust? From satellite imagery on Google Earth, we can clearly see the Haile Goubi volcano, just one of the countless craters scattered across this highly active geological range. When zoomed in, a series of volcanoes appear one after another, showing that Haile Goubi is by no means the only troublemaker. In fact, in terms of size, it is just one of the smaller volcanoes, a type of benign shield volcano, yet it is the source of the giant ash column that has shaken the entire area. The surrounding terrain bears the telltale signs of violent deformation, as if ripped apart by the enormous energy jets from the African superplum erupting from beneath the surface. The entire region is intensely active, as if something is silently shifting beneath the planet's crust. Moving further south, we find more recent volcanic activity. When we reach Dauphin, satellite imagery shows a large dike-like intrusion running between Dauphin and Fontal. Although the two volcanoes are not particularly close together, the distance measured by the mapping tool is still around 450 kilometers. This underscores the sheer scale of the geological system below a deep, interconnected network that is invisible to the naked eye, but whose activity casts a huge cloud of dust into the atmosphere. The African superdust plume is roaring across the region, revealing the resurgence of one of the largest geological features on the planet. And the question is becoming clearer: is this just a single event, or is it the beginning of a new geological cycle quietly emerging? We can see all of this on the seismic section. The cross-section shows two orthogonal sections of the African superplum, the most notable being the section from point A to A. This image maps the seismic velocity beneath Africa, showing a distinct region of extremely low velocities. This is a signal that the material in this region is softer, hotter, and more ductile. These low velocities belong to P waves, compressional waves similar to sound waves that travel through the Earth. When P waves slow down, it means that the medium they are traveling through contains hotter, lower density material characteristic of low velocity seismic provinces, which are often associated with strong volcanic activity. In depth, the picture becomes even more dramatic. The African supercolumn plunges deep into nearby South Africa like a giant root of the earth. From that great depth, it swells and spreads horizontally, forming giant lava flows that move silently beneath the continental crust. It is this slow but powerful movement that is literally ripping and breaking apart the structure of Africa. These seismic profiles are more than just scientific images. They're like slices of a secret that Earth has kept hidden for tens of millions of years. And that raises a curious question. Could the recent ash plumes, deformations, and eruptions be just a prelude to a much deeper transformation taking place quietly beneath our feet? Continents are considered to be the most rigid and stable geological structures on the planet's surface. They are formed from very durable rocks, the most common of which are felsic rocks, which are hard, strong, and extremely difficult to break. Think of granite, a material that is almost impenetrable under normal impact. However, the enormous energy rising from deep within the earth is so strong that it can bend, crack, and even separate these seemingly eternal continental plates. Much of this energy converges in Ethiopia's Afar region and then spreads south and even into the Arabian Peninsula. This is the heart of what is happening in Africa today. The pressure from underground has been building for months, years, even decades. And now it's starting to show on the surface. For the first time in a long time, we are seeing powerful eruptions from the Afar rift zone, which rarely produces events of this magnitude. This is, of course, still a volcanically active region. There have been sporadic eruptions between 2010 and 2020, but these types of powerful eruptions are not common. They are much rarer than in active volcanic systems like Hawaii, where the crust has been steadily building up with near regular eruptions. Through 2025, this increase in activity has scientists wondering, is this just a temporary reaction from a geological hotspot, or is it a precursor to a much more profound period of change that is about to unfold in the structure of the entire African continent? What is happening can be thought of as a series of giant energy reactions that originate at the core mantle boundary. There, convection currents and hot jets of material surge with an intensity that modern science still cannot fully explain. The cause may be related to geodynamic processes deep within the planet, but the fact is that we still do not fully understand why the energy is so concentrated in this area. As the hot jets of material surge up and begin to spread horizontally, the sudden drop in pressure causes decompression-induced melting. Solid rocks are forced to soften, melt, and form magma chambers just below the surface. As the pressure builds up again, they are squeezed like a pimple about to burst, and then boom, energy is released. That is exactly what happened here. Between 2015 and 2020, 20% of the known volcanoes in the entire East African Rift Zone system recorded unusual activity, topographic deformation, and a series of seismic signals. In just 5 years, 18 volcanoes simultaneously showed strong revival. This was accompanied by subsidence, surface displacement, and countless other fluctuations, all showing that this area is in a state of extremely high geological energy. And the worrying thing is that in and around that area, there are 5 million people living right on top of a huge active geological structure, a system that has the potential to change the face of the continent over geological time. The question is what we are witnessing just the beginning of a much larger cycle of upheaval? We understand a lot about this mysterious volcanic activity thanks to one special scientific indicator, helium-3 to helium-4 ratio. This is like a fingerprint of the Earth, allowing scientists to trace the origins of the energy rising from deep within the planet near the core mantle boundary. Helium exists in very different proportions than what we see near the surface. When giant mantle plumes like the Hawaiian system or the African superplum rise, they carry this primordial helium from depths of thousands of kilometers. Helium is a rare gas, so light that it almost doesn't bother to react with anything. It is this inertness that allows it to escape from the Earth without being trapped as a pristine witness to the processes that took place when the Earth was still red hot. Therefore, when scientists measured high helium trioxide to helium tetroxide ratio in Ethiopia, they immediately knew that the energy source erupting here had extremely deep roots, even deep enough to reach near the boundary layer between the core and the mantle, a place that science is almost unable to directly access. What makes the story even more intriguing is that the ratios were not scattered, but unusually concentrated in the Ethiopian and Afar domes. The epicenter of the eruption, researchers describe it as a distress signal from the Earth's interior, indicating that a stream of primordial material was trying to escape to the surface. Combining isotope data with satellite images of the giant ash plume suggests this was no ordinary eruption. It was more like a temporary opening where pressure from deep within the planet suddenly found its way out. And if the helium levels continue to rise in the coming years, it could signal the acceleration of a rising mantle supercolumn, a geological process that could reshape the entire African continent in the distant future. Asking the question makes many scientists shiver. Are we witnessing the first steps of a profound change in the structure of the Earth? If the helium signals were only the first clue, recent seismic observations have added to the worrying picture. Under the fragile crust of the Afar region, seismic waves are becoming more unstable, suggesting that the mantle is beginning to breathe more vigorously than usual. Several monitoring stations have recorded faint but frequent tremors, like the accelerated heartbeat of a giant body waking up after millions of years of slumber. The signals are not loud enough to cause panic, but they are enough to keep geologists in constant emergency meetings. Scientists are paying particular attention to new surface deformations along rift zones where the ground is being stretched at a rate too slow to be seen by the naked eye, but enough for satellites to measure millimeters of movement. Some cracks, tens of kilometers long, have widened in recent months, creating dark, zigzagging lines that act as early warning signs. Ironically, many of these cracks lie beneath densely populated areas where people go about their daily lives. Without even realizing they are standing on a seam of the planet. In that context, many experts began to hypothesize that the recent event may not have been just a single eruption, but the opening chapter of a new cycle of activity of the African mantle superpillar. Some models even predict that in the next few thousand to tens of thousands of years, the Afar region could separate from the rest of Africa, paving the way for the formation of a new ocean. A prospect that sounds far-fetched, but is backed by a wealth of geological evidence. Adding to the mystery are the uncanny similarities between the signals in East Africa today and those recorded before the Hawaiian supercolumn burst into full force hundreds of thousands of years ago. If the similarities are true, we may be witnessing a rare moment in geologic history about to take a new turn, one that modern humans have never seen before. Among the millions of people living right on that door, leading underground, the bigger question still hangs. What is really moving beneath our feet? And is this just the first warning before a much larger geological cycle of upheaval is brewing in silence? These questions have become more acute as the latest three-dimensional seismic models reveal a remarkable detail. The hot material rising under the Afar region is not simply moving vertically, but also fanning out in a wide-spreading pattern, as if the mantle is trying to rip the continent apart in multiple directions at once. Some geophysicists compare this phenomenon to seeing the first cracks appear in ice before a massive iceberg collapses. The change may be very gradual, but when it reaches a tipping point, it becomes sudden and violent. More worryingly, the mantle movement is not happening in isolation. Recent gravity magnetic measurements show that the crust in East Africa is thinner than usual, a sign that it is being stretched more intensely. This means that the crust is becoming more brittle, allowing small faults to quickly turn into large-scale rifts after just a few bursts of magmatic activity. Some cracks have increased in width by tens of centimeters in just half a year, a startling pace on geological timescales. Meanwhile, the international scientific community is increasingly interested in this phenomenon. Research teams from many countries have begun to flock to Ethiopia, Eritrea, and Djibouti to install more sensors, deploy seismic scanners, and send geothermal robots into deep fissures. Some scientists admit that they have never seen a rift system as active and intense as East Africa today, and even suggest that what is happening may be a scaled-up version of the tectonic process that created the Atlantic Ocean hundreds of millions of years ago. Yet there is another layer of mystery that has many experts particularly scratching their heads: the strange coincidence between the activity of the African superpillar and small but unusual fluctuations in Earth's magnetic field in recent times. While there is no direct evidence that the two phenomena are related, the possibility of a connection is quietly being considered. Some bold hypotheses even ask whether the changes deep within the planet are signaling a new cycle of magnetic field adjustment, something that has occurred in the geological past. Amid all this mystery, millions of people in the region continue to live their lives, sometimes hearing only brief reports of small tremors or limited eruptions. Yet beneath their feet, at depths unseen by humans, one of the Earth's most powerful machines is quietly churning, which raises one final and perhaps most important question. Is East Africa entering the early stages of a great tectonic shift, or are we simply witnessing one of the planet's many normal heartbeats? One that this time, for some reason, is stronger than ever. As we look deeper into the data, the mystery of the Afar region seems to widen. rather than shrink. Scientists have observed that seismic fluctuations are occurring not only under familiar volcanoes, but also in areas previously thought to be completely silent. This has led many experts to believe that the magma system below is becoming increasingly interconnected, as if the magma chambers are talking to each other through small pulses, signaling the coordination of a common energy source deep below. The latest models that simulate the movement of hot material suggest that a giant mantle tube network may be forming under East Africa. The network is not near the surface, but at a depth of nearly 1,000 kilometers, an area that can only be inferred from seismic waves. If the models are correct, it would mean that the entire foundation of the African continent is being slowly reshaped from below, like a building whose foundations are being silently altered without anyone on the upper floors noticing. The existence of this network could also explain simultaneous changes in regions hundreds of kilometers apart. An eruption in Afar might trigger a small tremor in Tanzania. A new rift in Eritrea might coincide with a small change in the rate of surface movement in Kenya. These coincidences are too regular to be random, leading researchers to consider the possibility that East Africa is in a pre-rift phase, a period that typically lasts millions of years, but can be more clearly identified when small events are continuously linked together. Interestingly, some ancient geological records have suggested that the region may have experienced a similar hot period tens of millions of years ago, but no one knows exactly what happened after that. Some theorize that the last rifting stopped before it was complete. More daring theories even ask whether the Earth has some sort of mantle rebound cycle where hot columns of material rise, and then sink back down after releasing their energy. There's no strong evidence to support this, but the suspicious repetition of some of the signals has scientists taking a closer look. At the same time, a series of Earth-observing satellites, including Sentinel, Landsat, and commercial satellites, began to record subtle changes in the land's structure, dark patches, spreading the land surface, rising or sinking a few millimeters each month. When this data is overlaid over time, the topography of the Afar region looks like a fabric being pulled taut by an invisible force in the middle. If this trend continues, scientists predict that in a few hundred or a few thousand years, a major rift tens of kilometers wide could appear, creating the seeds of a new inland sea. And when water from the Red Sea or Indian Ocean floods in, the African continent could be permanently split in two. Of course, it's a far-off prospect, but what makes it also fascinating and a little bit terrifying is that we're witnessing the first signs of a major tectonic shift in the Earth's history, a process that in geological history has usually only left traces in the form of fossils or strata. But this time, we're seeing the beginnings unfold right before our eyes. And so the new question arises: how much of what is happening is the natural workings of the planet? And how much is a precursor to a period of great upheaval that science does not yet fully understand? This is a developing story. I will keep you updated on what is happening here. We monitor everything that is happening energetically on Earth: earthquake activity, volcanic eruptions, geophysical events like geomagnetic storms. We also look at solar activity, space weather, planetary resonances, and cosmic forces and events, as many of you know. So if you like it, please subscribe. Hit the like button, and help the channel grow. Thank you all so much for watching.